Hello everyone, welcome to attend our class. Today we are going to study section 6.10, Design Method of High-Strength Bolt Connections in China. Next, we will study section 6.10.1, Calculation Method of High-Strength Bolts Friction Type Connection, and section 6.10.2, Calculation Method of High-Strength Bolt Bearing type connection in China. The friction type connection transfers the internal force by the frictional resistance between the connected parts, and the shear force caused by the design load cannot exceed the frictional resistance capacity. The three methods to apply protection to high-strength bolts in engineering are angle method, torque method, and torsional shear method, respectively. The design pretension of high-strength bolt is calculated by the formula, which has considered the influence of material inhomogeneity, avoidance of overstretch during construction, adverse effect of torque when tightening the nut. The slip coefficient of the friction type connection is mainly related to the steel surface treatment process and the coating thicknesses, and the slip coefficients can be obtained in this table, which is from the Code of Design of Steel Structures in China. The bearing capacity of the friction type connection depends on the friction force of the contact surface of the member, which is related to the pretension of the bolt, the slip coefficient of the friction surface, and the number of the friction surface of the connections. The design value of shear capacity of single high-strength bolt friction type connection can be determined by this formula. The test shows that when the external tension is greater than the pretension of bolts, the pretension in the bolts decreases after unloading. That is, the phenomenon of relaxation occurs. But if the external tension is less than 80% of the bolt pretension force, no relaxation will occur. Therefore, in the high-strength bolt friction type connection that is poured along the axis of the rod, the design value of the tensile capacity of a single high-strength bolt is equal to 0.8 times of the pretension force. And the action of shear force, the average shear force of a single bolt is equal to the total shear force divided by the number of bolts, which must not exceed the shear capacity of a single bolt. Thus, the number of bolts required for a high-strength bolt group and axial tension is equal to the total shear divided by the shear capacity of a single bolt. For friction type connection, part of shear force is transferred by the contact surface in front of the hole, which accounts for 50% of the bolt's transfer force. So the calculation formula of the net cross-section can be obtained. In addition, it is necessary to check the strength of the net section of the plate, and the action of moment when the bolt is and falls along the direction of bolt bar, the contact surface of the connected member can keep close contact all the time. Therefore, it can be considered that the neutralization axis is on the centroid of the bolt group, and the force in the outermost bolt is the largest. So the formula for calculating the maximum tension of high-strength bolt group can be obtained, which must be less than the tensile capacity of one single bolt. The ultimate state of bearing capacity is the shearing of bolt rod or the extraction of the whole wall. Therefore, under the action of shear force, the design formula of bearing capacity of high-strength bolt is the same as that of the ordinary bolts. In tensile connection, the calculation method of the design value or tensile capacity of the high-strength bolt is also the same as that of the ordinary bolt. In the connection bearing both shear and tension, the joint effect of shear and tension should be considered for the high-strength bolt bearing type connection. This formula is used to judge whether the connection is safe. In the formula, 1.2 is the reduction coefficient. That is all for Chapter 6. Thanks for listening.